How's it grade 11s? So continuing with differentiation using rules. With this video, I'm going to be showing you how to be going through product rule, quotient rule, and the chain rule. Okay. So this is example 2. Question A. So what they're asking here is dx of x cubed minus 2x to the power of 2. Now, what we're going to be using here is we're going to be using the chain rule, okay? Now, how do I know it's going to be the chain rule? It's because we have a function within a function. So what we've got here is we've got the inner function, which is this x cubed minus 2x. Then we have this outer function, which is that thing squared. So basically what we've got here is we've got two functions. I can call the first one f of x equals x cubed minus 2x. And then I can call the outer one g of x equals x squared. So this is the red one. And this is the green one. Okay. And how we get this one combined is this would be g circle f. Okay. And you guys have seen that. Guys, please don't say things like goff and fog and stuff. It's g circle f, f circle g. Okay. And then you guys should have done this in grade 10, where you take this function, put it within that one. So this is chain rule, function within a function. And how we read this, it's saying differentiate this thing with respect to x. So if you remember from the first video, if they give it to us like that, if they give it to us as a dx of something, all we have to do is go straight into writing the derivative. We don't have to write anything like a dy dx or an f dashed. Okay. So how do we do the chain rule? Well, we differentiate the outside function first. And our outside function here is the green one, this x squared. So it's just like what we normally do. We take the exponent multiplied with the front. Now just remember that there is an invisible 1 there. So 2 times 1 is 2. Now I'm going to write the inner function, x cubed minus 2x, and then I decrease that power by 1. So all I've done there is I have differentiated the green one, okay, the outside function. Now what I need to do is I now need to differentiate the inside function, or the red one. So to differentiate this, 3 times the 1, remember that there's a secret 1 there, 3 times the 1 is 3. Decrease that power by 1 and we get 2. And then over here, that one's exponent is 1. There's an invisible 1 there. So 1 times minus 2 is minus 2. Decrease that power by 1 and we get 0. X to the power of 0 is 1. So that's just 2 times 1, which is just 2. Okay, so let me just show you what we've done here. This green bit is the derivative of that bit, and then the red bit is the derivative of the inside function. Okay, so you always differentiate the outside one first, leave the inside, then differentiate the inside, and then that's the derivative of that one. All right, let's go on to question B. Here they're asking us d by dt of t to the 4 plus 2t squared minus 6 to the power of 15. Okay, so again, grade 11s, we have the chain rule. We have an outside function, which is this 15-bit. Okay, then we have an inside function, which is this t to the 4 plus 2t squared minus 6. So again, they've asked us in this form here, when we've got something like d by dx, but this case is d by dt, it's the same thing, of something, we don't write anything, we just go straight into the derivative. Okay, so what this is saying, differentiate this whole thing with respect to t. So it's chain rule. We've got an outside function, inside function. So we differentiate the outside function first. So 15 times, remember there's a 1 in the front here. 15 times 1 is 15. We leave the inside. And then we decrease that power by 1. So what we've done there is differentiated the outside function. Now we need to differentiate the inside function. So the derivative of this would give us 4t cubed plus 4t. Then just remember that the derivative of a constant is 0. So we got plus 0 there, which I don't have to put. Okay, and there's the derivative of that one. All right, so let's go into question C. We've got dk of k cubed plus 3k minus 2, 3k to the 4 minus 2k squared. Now, you can see that this one is totally different compared to these first two. We do not have a function within a function. What we've got here is we have a function times another function. Okay, and what we call that one is we call that one the product rule. Okay, so it's this one over here, a function times a function. And guys, these things will be given on your formula sheet. Okay, so how we do a function times a function, again, it's given to us in this D form. So differentiate this thing with respect to k. We can go straight into the derivative. And how we do this when we've got the product rule is we differentiate the first, keep the second, then plus keep the first, differentiate the second. So let me show you what I mean by that. I'm going to differentiate the first. So we're going to differentiate the blue one. So this will be 3k squared plus 3. Keep the second, 3k4 minus 2k squared, plus keep the first, k cubed plus 3k minus 2, differentiate the second. So we get here 12k cubed minus 4k. All right, so differentiate the first, keep the second, plus keep the first, differentiate the second. And that is your product rule. All right, going on to question C. Question D. Okay, d by dp of p squared plus 3p minus 4 over p squared plus 2. All right, now I just want to go back to that first video that we had. And I just want to show you something here. You remember with this example over here, they said without using the chain rule. And I said to you, the reason why we can do that is because we only have a single term in the denominator. Okay. If you have a single term in the denominator, you can split it the way we did here. Now, the problem with this one is we do not have a single term in the denominator. We've got two terms. Grade 11s, we have no choice. We have to use the quotient rule, okay, in order to differentiate this because we've got more than one term over here. So if you have a look at the quotient rule, this is it over here. Now, I know it looks confusing, but rather watch the example and see how we do it, okay? So as you can see, we have a function in the top and a function in the bottom, okay? And what this is, it's saying, differentiate this thing with respect to p. So we can go straight into the derivative. Now, when you have to use the quotient rule, it's going to be the derivative of the top multiplied with the bottom. So let's differentiate the top here. So the derivative of this will give us 2p. Derivative of this plus 3. And then that just falls away. So that's the derivative of the top. Then we leave the bottom. p squared plus 2 minus. Then we leave the top, p squared plus 3p minus 4. Now we differentiate the bottom. So the derivative of the bottom would give us 2p, and then that 2 falls away. Okay, so let's reiterate. Derivative of the top, leave the bottom, minus, leave the top, differentiate the bottom. Okay, all over the bottom squared. And that is your quotient rule. Okay, and you can leave it just like that for me. All right, guys. So this is a tricky one. So just practice on this type of one for me. All right. Right, we're going on to question E. We've got dx of 2x plus 1 in a square root. Okay, now just like we've done with square roots before, I don't want to be dealing with surds. So I'm not taking the derivative just yet. So I still have to write dx, and this is going to be 2x plus 1 to the power of a half. Okay, this is chain rule. Okay, we have a function within a function. So what I'm going to do is I'm going to differentiate the outside function first. So half times the one in the front there is going to give us a half. Leave that inside. Decrease the top or the power by 1. So we get minus a half. Now I must differentiate the inside. So derivative of 2x is 2, and then that just falls away. All right, so now we can simplify this, guys. The 2 and the half will cancel, and we never write things with a negative exponent, so this would be 1 over 2x plus 1 to the power of a half. And that is your answer. All right, guys. So what I would like you to do now is question 2 for me, please. Thank you, guys.